Did. Okay, this is about okay. Now remember, this one is I already explained to you what is the meaning of. I just wanted to show here. So the 81, and there's another one below this. Here, I just want to show total. So this is the focus here. Total distance. So when you want to find total distance, it is nothing but integral of directly a to b, maybe a to b, absolute value of the velocity function, or we say instead of velocity function it is a to b of, now this will be like what if I want to take x, then this becomes x, that it changes 1 1 2 2 3 3, so I'll put an x here, so x, and instead of velocity is change in displacement, that's all it is. If you look at this, ds by dt is nothing but, so you want to know what is the total distance of the particle travels from 0 to 5. So you can say, okay, directly it's at 0 to 5, so this becomes your 0. Let's write it again, integral of 0 to 5, and this is absolute value of s dash of. So please go through this. It's telling us you need to take the absolute value of the velocity function and you get this answer. But I want you to understand that there's one more thing you have to take care is if s is increasing, now remember if s is increasing means s dash t is greater than 0 in 0 to 2, and s is decreasing means s dash of t is less than 0. So you could be given an option instead of this, you could write it as 0 to 2, because it is until 2 it is increasing, so positive, so you can just write st without the s dash of t, and then plus 2 to 5 with absolute value. So that also is right. Or you could also write this as 0 to 2 of s dash of 2, and take away this absolute value and change minus 2 to 5 s dash of 2. Okay, so this is how different way you can write down the answer. Either this, sometimes it looks like one of this is right. He doesn't tell you anything in the beginning how far is the particle, so so this is not an option at all. But instead of this, they could have given you 0 to 2 like the way I wrote here, and minus 2 to 5. So if that was the case, then this could be also right. So take note of that. Confusing? I hope you understand. This is a temperature problem. Let's see. I'll just do this quickly. You please read the question first. There is a x-axis, y-axis. Let's say this is 200. The cup of tea or coffee, whatever it is, in the beginning the temperature is 200. The room temperature is given to you as, if you read this, it is 70 degrees. This is the room temperature, so 70, and in the beginning the coffee is given by at every minute it tells you what is the, and you see there's a minus here, so something like this. And one thing is clear, there is a horizontal asymptote where finally the coffee will be the temperature can come as close as 270 degrees of the room temperature. Now all this thing is not required, but what is important is how to apply the formula. You remember the same thing formula I wrote, fx is f of a plus a to x and df by dt, that's all it is. But in this case, the f is temperature, okay, and he's asking us what is the temperature of the tea after 4. So just put instead of f I'm going to put it at t of, see, t is, so t of 4 is, so initially the temperature is given to you as when t equals 0, here it is. This is very important. When the temperature is 0, it means this t of t, it means t of 0 is 200. So that's like here. Since I'm using instead of capital F, it's the temperature I put. So it is t of 0 here, and this will be your 0 here, and this will be your x will be your 4. Okay, I just wanted to say it's going to be 4, and this is the derivative, at what rate the temperature getting reduced. This was here. So t of 4 is 200 plus integral of 0 to 4, and you put this one here, minus 6.89 e raised to minus 0.53 t dt. Okay, so on your calculator just do this. This plus will be minus 200. On your calculator put maths 9 integral with boxes. Put the boxes here, and you get, make sure you get the answer as 24.83. This whole thing. This part will be this one, and when you subtract, you get your answer as 175 degree Fahrenheit. Most of the time they ask the same question here. I use capital T because of the temperature of the coffee, and the formula I always use capital F, and the derivative of capital F. But now they use RT. RT is the rate of change of the temperature. So that goes here. The derivative function goes here. And this is the geometry of it. It's like after 4 minutes, like say 1, 2, 3, 4 minutes, maybe the temperature has gone to, this is like, this is just rough sketch. It doesn't make sense actually. Okay, this is 4. So at 4 it is 175. Now this number should have been here. It's okay. We just did it. Because in the beginning the temperature goes down very fast and then slows down. And towards the end, as the time passes, it comes near to the 70 degree, which is the room temperature. So that was 81, right? Okay, this problem number 82, the derivative of f is given, so this is a f prime on the interval minus 2.5, at which of the following values of x does f have a relative maximum. Now what is the meaning of relative maximum is, first of all you have to see where the derivative is 0. So you have to understand what is the meaning of relative maximum or minimum. So first thing is your derivative has to be, let's see, at x equals c, it has to be either 0 or undefined. And secondly, if you want to have a maximum, this switch sign, plus to minus, something like this, it is maximum. So here it is 0, but here it's plus, and here it is minus. Here it is 0. The slope here is positive, then 0. So we need to figure out where does it become 0. So to know that, you can use your calculator. On the calculator mode, go to the y editor, put this x cubed minus 4 sine x squared plus 1, and then since you are supposed to know from minus 2.5 to 2.5, go to the zoom, or in the windows, since it is given to minus 2.5, go to the minimum minus 2, minus 3 to 3, the x-axis. Okay, and on the y-axis, I believe you can even take from minus 5, minus 4x cubed, minus, take it as minus 6, and accordingly change it. But you will see, I already have done it. It goes something like this. This goes right down. And this is like your 1. You can zoom and check it, and you will see that this is the point where this is the derivative f dash. F prime is 0 at this point, and using the option in the second cal, go to the option of 0 and blink the cursor here, lower bound, then take it to the right, and you get the answer at 0.54. So you get that, and you'll also see here, this graph is above the x-axis, but slope is positive. This graph is below, slope is negative. So it satisfies this condition, plus 0, minus. So to the left side, the red graph is above, the first derivative is above the x-axis, so plus. On the right side, it's negative, so it makes sense to understand that it has a relative maximum at 0.5, this part only here, but not here. The reason from here, this is from minus to plus a, and if you see 2, and this goes like that, this is something like this, and this one goes like this. This is also minus to plus, so the only option is plus 0 minus. This is minus 0 plus, this is minus 0 plus. So even this point also the derivative is 0. They switch the sign, but they go from, this is minimum, relative minimum, but this one is relative maximum. Hope makes, you can check also, the rest will be, you don't have a point which passes through the x-axis, or even if they pass, they will pass maybe beyond 2, after 2.5, to the left of 2.5 or to the right of 2.5, but in between 2.5 maybe here, and until this side 2.5 here, you won't see anything. Okay, so that was problem number 82. Check 83. Let's see 83, how does it go? You have to use a trapezoidal rule. What is a trapezoidal rule? For this, I just want you to know that trapezoidal rule like this. Suppose you have if I draw a graph like this, see this, and from this point and to this point, I want to know the area. I just divide this. What is the trapezoidal rule says is you can join this word like this. Like this. So you have you can say, since this is the starting point here, this is the ending point, you have the width, and then you have a trapezoid all the time. So like your width. So you are using the first trapezoid, the second trapezoid, the third trapezoid. This is an example for the first one. So the formula is always, let's say this is your A, f of a, no, let's say a, and in between you have, let's say, p and q here. So it's always f of a trapezoid is half height times b1 plus b2, the two bits. Now here they are paired. This is like your fa, this is your fp, this is your fq, this is your fb. So what you're doing is, when there is a formula I'll give directly, there's no time to explain all this. So it is h over 2, and then write f of a, but plus twice, this 2 will be repeated. So f of p plus f of q, and then this one is only once. So this is how you have to do. Just have a look at the formula that I showed, and directly I will show. Look at this formula. Okay, so you can clearly see that the formula is h over 2. H is that the distance between the small distances between the two parallel lines, and why it is going down. Oh god. Trying to fix it. Ah, there you go. Okay, so let's see how do I apply it right here. So in the problem, you can check it after. So here you have, this is like your first one, like how you have this A here, this is your A starting, sorry, this is not A, this is your A, and this is the last one, B, and those are important in between one. So what you have to do is, by trapezoidal rule, the area is h over 2. So now the h here is, h is the width. Look at this width. 0 to 5 is 0 0.5, 0 0.5, 0 0.5, 0 0.5, 0 0.5. So 0 0.5. So 0 0.5 divided by 2 according to the formula. And then you have this one is f of 0. So that comes only once. But the rest of this has to be repeated twice. So it is 2 times 4 plus 10 plus 18 plus 20 plus 40, then plus 54 only once. Okay, and if you work on this, you will see there's a 2 here. I can just make it smaller. 2, 2, and this goes to 2 2s are 4, 727, and add all this and multiply by 0.5, you will get the answer as 62. Then you are done. So this is the important part. First number and the last number is written only once, but the in between is multiplied by 2 because trapezoid rule is being used, and h is the height. Okay, but I think I made sense. It's 84. It's an easy question. So look at this. It clearly shown here. You have this is a discontinuous function. You can clearly see this. The f, the value of f or the y coordinate. So the heights, they go on increasing, and they come near to, when you approach to A from the right side, sorry, then the height becomes, the height is 2. And if you approach from left side, you see, again it comes near to 2. So both the sides the left limit and the right limit is same, but there's a hole here, it's empty, because at f of a is 1 here, look at this. F of a is 1, but f of 2 is not, sorry, f of a is not 2, but f of a is 1. So based on this, you will see the answer is limit of x tends to a of fx is 2, because both the sides, the red ones, they go close to the green height, which is 2, and the blue height, again they go on, they become smaller and smaller, and then become again the 2. Okay, so that takes care of that problem. This is a particle moves in the x-axis. What it's telling us is, please read the question nicely, not difficult. You have to use your calculator. Particle moves along the x-axis, so that the t is greater than 0 is positioned by this is the main thing. So what you have to do is, on your calculator, in the y1 editor, you need to know what is the velocity of the particle at the first instant the particle is at the origin. What it means is, this is the distance graph. So there, as the time progresses like this, the particle moves up, right? So it may be going down or up, but depends on either up or down. But it's over here, somewhere here. But there will be one. I believe if you put t equals 0, what is t? If I put t equals 0, this whole thing becomes 1. It's like it starts here. Particle is here. And then it goes down now. We have to see when it goes to the starting point. So starting point means that somewhere here it will be cross the x-axis. So that is what we have to figure out. What is this t equals question mark? And once you get this, then we need to figure out what is the velocity the first time it crosses the x-axis. So what you do is, first on your y1 editor, put cosine of root of x, because on your calculator you have to put x even though there is a t, just to help us out where does it pass. And you will see this goes, this point, your graph will show something like this. You zoom and do accordingly, see where does it go. Use the second cal and go to 0, and you blink, use the cursor here, then you take the cursor here, and you get the answer as I think I made a mistake, let me check. 2.4667. So when the time is your t equals 2.4 seconds, that's where the particle goes back to the regular starting point and goes towards other side. So that's what it means. So negative distance, so goes to the other side. But let's see now. We need to figure out what is the velocity. So this one I'll write here. X test. Take the derivative of this.